Is over multiplying fractions and whole numbers. But before we do that, let's talk about this. How do you know 1 and 2 tenths times 0 and 6 tenths is equal to 72 hundredths? And 1 and 2 tenths divided by 6 tenths equals 2. Several ways you can do it. Tenths place times tenths place is hundredths. I'll give that so far. 12 times 6 is 72. Another way you could do it is this way. Line up the decimal point and multiply. So there's 2 digits behind the decimal point. So I need 2 digits behind my decimal point. 7,200. Another way to do it is you multiply as whole numbers. 12 times 6 is 72. There are 2 digits behind the decimal point. 2 digits behind my decimal point. 7,200 hundredths. What about this one? 1 and 2 tenths divided by 6 tenths equal 2. So let's set it up as a division fraction. So it's asking how many groups of 6 tenths go into 1 and 2 tenths. You know what? I don't care for working with decimals here. So I'm going to change this divisor into a whole number. What power of 10 can I multiply 6 tenths by to get 6 whole? Multiply, this is the tenths place, so I multiply by 10. Multiply by 10, 1 and 2 tenths is 12. 12 divided by 6 is 2 groups, so that's correct. Another way you can think of a shortcut, if you do not like multiplying by the powers of 10, you move this decimal point 1 place over, so 6, move this 1 place over, that's 12. 12 divided by 6. So let's go to our lesson over multiplying. Here are the 3 Stooges. I don't know if you noticed, it's black and white. I don't think I've ever watched the movie before. It's Moe, Larry, and Curly. So, should this be Curly? Because he has curly hair. I don't know. Don't get it. All right, so Moe. He says when you multiply a positive number by a fraction greater than 1, so you multiply by a fraction is greater than 1, the answer is always bigger than the original number. Larry states, I think sometimes the answer is bigger if you multiply a positive number by a fraction greater than 1. But sometimes it's not. So sometimes it does work, sometimes it doesn't. And Kyle, Curly states, I think when you multiply a positive number by a fraction greater than 1, the answer is always smaller than the original number. So which Stooge do you agree with? I think I agree with Mo. When you're multiplying something larger, greater than 1, the quantity will become greater. But let's show our proof. So I'm going to take out my calculator right now. It says use a calculator. Whoops. I don't know if you saw my password. All right, so let's look at this. Calculator feature. All right, so let's start with first one. You start with 15 hundredths, 1 and 8 tenths, 10, and 240. You're going to multiply, the rule says multiply each one of these decimal by 3/4. Do you know the decimal equivalent of 3/4? It says 3 divided by 4. Using your calculator, 3 divided by 4 equals 75 hundredths. So I'm going to multiply each one by 75 hundredths. So if you multiply 7500 by 15 hundredths, you get a really small number. If you multiply 7500 by 1 and 8 tenths, you get 1 and 35 hundredths. If you multiply 7500 by 10, you will get 7 and 5 tenths. And you multiply 75 hundredths by 240, you will get 180. So let's think about it. I started with 15 hundredths, then I multiplied by 3/4. It got smaller. If you don't know why, I fixed some placeholder here. 1,125 10,000ths place is smaller than 15 10,000 place. And as you see, it's getting smaller. Let's go to the next slide. So, start with 1,500, 1 and 8 tenths, 10, and 240. Multiply by 7/5. Again, how do you read this? 7 divided by 5. Using my calculator, I multiply 7 divided by 5, and I get 1 and 4 tenths. So I multiply 1 and 4 tenths times 15 hundredths, I get 21 hundredths. If I multiply 1 and 4/10 times 1 and 8/10, I get 2 and 52 hundredths. If I multiply 1 and 4/10 times 10, I get 14. And if I multiply 1 and 4/10 times 240, I get 336. So I started with 15 hundredths, and then it became 21 hundredths. So what can you describe this as? The quantity has increased. I started with 1 and 8/10, it went to 2 and 5200. It increased. 10 increased to 14 because I am multiplying by 1 and 4/10. So what do you notice about the rules for each of these tables? From what I found, if you multiply by a number less than 1 whole, it's getting smaller. If you multiply by a number that is greater than 1 whole, it gets greater. So when you multiply by a fraction that is less than 1, the product will decrease. And when you multiply by a fraction that is more than 1, your product will increase. Let's go back to our introduction. Curly, Mo, and Larry. Mo says when you multiply a positive number by a fraction greater than 1, it will get bigger. He is correct. It will not get smaller, and not sometimes, it always gets bigger. Here's the proof. When you start with a number, you multiply by a fraction that or number that is greater than 1, the product will increase. The quantity will increase. So let's get to our other ones. So now that we understand increase and decrease, now we can answer some of these questions. Alex had 1/3 slice of cheese, 1/3 slice of sausage, 1/3 slice of pepperoni, and 1/3 slice of supreme. What is the total number of leftover slices? Shade the pieces below to represent 4 slices of 1/3. Done. Write as repeated addition. So he ate 1/3 cheese, 1/3 pepperoni, 1/3. Oh, those are leftover. He did not eat 1/3 cheese, 1/3 pepperoni, sausage, and supreme. So in other words, he had 4/3 left over. Did you know repeated addition is just really multiplication? So I see 4 groups of 1/3. And that's, so solve and write as a mixed number. So we have 4/3. Is there another way to say this? You did learn this in elementary school. How many groups of 3 go into 4? 1 group. What do you have left over? 1. 1 and 1/3. So 4 groups of 1/3, or 4 times 1/3 is 4/3, or 1 and 1/3. So repeated addition, multiplication. I wonder how they came up with 4/3 through this multiplication. 4 times 1/3 is 4/3. I'm not sure. It's 4 times 1 is 4. 4 times 3 is 12. Is that the mathematical way of doing it? I'm not sure yet. You know what? Let's do a couple more examples and figure out. Next one. 3 times 5/8. Shade the circles below to represent 3 groups of 5/8. So we divide each circle into 8 parts. So shade in 3 of them, shade in 3 of them, and 3 of them. Write as repeated addition. So it says 5/8, 5/8, 5/8. So I have 5/8 plus 5/8 plus 5/8 adds up to 15/8. Write as a multiplication sentence. 3 groups of 5/8 must equal 15/8. Solve and write as a mixed number. So I solved it, it was 15/8. What's another way to say it? How many groups of 8 go into 15? 1 group. What do you have left over? 7/8. So 15/8 or 7, 1 and 7/8. Some people like repeated addition. If you like repeated addition, keep on doing it. Some kids say, no, I'd rather just multiply it out. But I still cannot figure out how to get 15/8 from this. Let's see. No, let's see. There's 3 groups of 5/8. So I know it's 5, 8, 5, 8, 5, 8. So 15. So it's 5, 5, 5. Repeated addition, 8. Because they're cut into 8. You know what? Maybe I figure out by the next slide. 5 times 2/3. Shade the circles below to represent 5 groups of 2/3. So let's divide each graph into thirds. So 2/3, 2/3, 2/3, 2/3, 2/3. So write as a repeated addition. So I have 2/3 plus 2/3 plus 2/3 plus 2/3 plus 2/3 equals 10/3. 2, 4, 6, 8, 10/3. Write as a multiplication sentence. I have 5 groups of 2/3 equals 10/3. Solve and write as a mixed number. 10/3 is equal to how many groups of 3 go into 10? 3 groups. That's 9. That's 3 and 1/3. 5 groups of 2/3 or 5 times 2/3 equals 10/3 or 3 and 1/3. Again, to check your work, 3 times 3 is 9 plus 1 is 10/3. You multiply the denominator by 3 and then you get 9. You add the numerator to it, you get 10/3. So now I need to figure out this now. So I could do repeated addition. Some of you will just stay at repeated addition because you think it's way easier. There's nothing wrong. I won't not criticize, but it's not very efficient. So there must be a better way with just multiplying. So I know you have 2/3. It repeats 5 times. So I can see that 5 times 2 is 10. But from what I can tell, you keep the denominator by itself. So that is 10/3. I think that's how. Another way to do it is write this whole number 5 as a fraction. When we talked about rational numbers a few tutorial videos back, 5 divided by 1 is the same as 5. So 5, 1 times 2/3 is 5 times 2 is 10. 1 times 3 is 3. So it's 10/3. So several ways you can do it. So some kids just multiply 5 times 2 is 10. They keep the third alone. There's nothing wrong with that. Another way to do it is they set this up as a fraction. They turn this whole number as a fraction as 5, 1, and they multiply straight across. So how do you multiply a whole number in fraction? You can keep it as repeated addition. Another way to do it is turn the whole number to a fraction, and you multiply across, and you simplify, if possible. And usually it is possible. So does that really work? Let's see. Let's go back to previous one. Turn this to a whole number, 3, 1. This 3 divided by 1 is 3. Then multiply across, 15, 8. Hey, it works! And then simplify possible. Let's see if this one works. Turn this to a whole number, that's 4, 1. Multiply across, 4/3, and then you can simplify to 1 1/3. So again, some people do not prefer, they do not like that way. They rather just multiply 4 and 1 is 4, keep the third by itself. It's your rule, decide what you're familiar with. So let's practice this. Shade the circle below to represent 1/4 of 12. So I see 12 circles, 12 cupcakes. I want to divide it into, I want to put them into fourths. Fourths. Let's see, if I do it this way, no, that's thirds. I divide it into fourths. Fourths. Let's see. This will be this one. Let's see, did I divide this into fourths? Yes, I did. So 1/4 of 12 equals 3 circles. Another way to do it is think of repeated addition. So you have 12 groups of 1/4. Oh, goodness gracious. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. If you add all these fourths, you get 12 fourths, which equals to 3. That's, some people like repeated addition. I don't. It's not efficient. So there must be another way to do it. So we have 1/4 of 12. So 12 times 1 is 12. And then keep the denominator alone, 4. Or set this up as a fraction. Turn this whole number to fraction. Multiply across. You get 12/4, which is 3. Next one. Shade the circle below to represent 2/3 of 12. So 2/3 of 12 are two groups of 1/3 of 12. So I need to divide this into thirds. Oh, I just did that in my other one. Here are thirds. So it said 2/3. That's two groups of this. And that will equal 8. What if you do not like it this way? You can do this way. 2/3 of 12 is also saying 12 groups of 2/3. Oh. So that means I will repeated addition. I will have to do 12 groups of 2/3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So if you add those all up, you get 2, 4, 6, 8, 10, 12, 13, 16, 18, 20, 22, 24. 24/3 is improper. How many groups of 3 go 24? 8 times. Hey, it works. Again, it's not very efficient. I do not care about doing this way. So there must be another way. So we have 2/3 of 12. So 12. So as you can see, 2 repeats 12 times. So 12 times 2 is 24. You keep the third. Another way to do it is turn this 12 into a fraction by putting 1 underneath it, because 12 divided by 1 is 12. Then you multiply across, you get 24/3, right? All right, so the word of, if you haven't figured out by now, means multiplication. So for example, if someone goes to you and say, give me half of your 16 cupcakes. So half of the 16. You can do repeated addition, 16 groups of 1/2, add it over and over and over and over. Or you can do multiple, because you know the 1 would repeat 16 times. Keep the denominator the same, that's 16 halves, or 8. Or turn the 16 to a fraction and multiply across to get 16 to 4. So let's do it. So 7 groups of 3/4. That means 3/4 plus 3/4 plus 3/4 plus 3/4 plus 3/4 plus 3/4 plus 3/4. You can add all those up. I'm not. So we know 3 repeats 7 groups. That's 21/4. Or how many groups of 4 go 20? 5 groups, 1/4. That's one way. Or turn this into a fraction. Multiply across 21/4, or 5/1/4. Next one. 8 groups of 2/5. 2/5, 2/5, 2/5, 2/5, 2/5, 2/5, 2/5, 2/5. Repeated addition. I'm not going to do it that way. So I know that 2 repeats 8 times. That's 16/5. Or how many groups of 5 go to 16? 3 groups. And that leaves me 1/5. 3 and 1/5. Or another way to do it, turn this whole number into a fraction. Multiply across 16/5. Next one. 7 groups of 2/3 of 7. I think I missed a slide here. One of my slides I was going to say is 2/3 of 7, 2/3 times 7, is it the same thing as saying 7 times 2/3? Are they the exact same thing? Yes or no? I would hopefully you said yes. Because let's use an example. Why? 3 times 4. Could you rewrite it as 4 times 3? Would they both equal 12? Yes. It's called commutative property. It goes forward and backward. Think about it when we multiply integers. -3 times 4 is the same as saying 4 times -3. So what's the opposite of 3 groups of 4? That's -12. Or what's 4 groups of -3? That's -12. So let's do it. 7 groups of 2/3. 2/3, 2/3, 2/3, 2/3, 2/3, 2/3, 2/3. That's a lot of thirds. That's 14 thirds. Another way is you're going to repeat this 2 7 times, 14 thirds. That how many groups of 3 go to 14? 4 groups. It's 12. So 4 and 2/3 is the other answer. Another way to do it is turn this whole number into a fraction and multiply across 14 thirds. And last but not least, 1/2 of 9, half of 9. Half of 9. should be able to do it in your head. Half of 9 is 4.5 or 4.5. If you cannot do it in your head, you do 9 groups of half. Half, 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 half. I'm not going to do repeated addition. So we know that the 1 repeats 9 times, so that's 9 halves. Another way to do it is turn this whole number into a fraction, multiply across 9 halves, or 4.5, or 4 by 10. So the main thing is, in this activity, I wanted you to figure out, is 3 ways you could do this. Repeated addition. Multiply and keep the denominator the same. Or the most efficient mathematical way is turn the whole number into a fraction by putting a place on 1, because you're not changing its value, and multiply across and simplify.